Before we get started, a quick note. If you haven't yet, please listen to episodes 2 through 4 in this season on Learning to Change, where we tell the stories of 3 groups who've modeled our season theme. We had to cut so much good stuff out to create those stories, so now we're releasing extended cuts of the individual interviews. We hope you'll like them as much as we do, and that they lead you to a richer appreciation for what it means to learn to change.
Welcome to Climate Conversations.
In today's episode, we're going to play an expanded version of the interview that we had with Lauren Kuntz. Lauren was a student in the MIT Terrascope program and has just recently completed her PhD in a climate science program at Harvard. We had a great conversation with Lauren and really wanted to share more of what she had to say about her experience, both in Terrascope and what she's been doing since then.
So today we are learning to change with Lauren Kuntz, Dr. Lauren Kuntz, I might say. Congratulations.
Thank you. Who
is a recent graduate of Harvard University, but before that was at MIT. And we at Climate X are really, really keen on finding out how her experience with Terrascope, which is a very active learning environment at MIT, made her who she is today. Thank you for joining us, Lauren.
Thanks for having me.
Yeah, so could we take us back to the moment you're entering MIT and trying to get your bearings here and figure out what you want to do. Yeah?
Just tell us what is it like to enter MIT? Because I've never done that as an undergraduate.
It's simultaneously exciting and overwhelming and terrifying all at once. You're just kind of thrown in and you're like, I'm so grateful to have been accepted and to be coming here. And at the same time wondering, like, can I actually make it here? Did they make a mistake? Should I not be here? So all these questions sort of going on in your head, and you just want to get rolling, want to get started and be like, okay, I can do this.
And how did you get to Terrascope from that moment of excitement?
Yeah, so Terrascope actually sends out mailers to every incoming freshman over the summer. And I originally saw it and threw it out. And fortunately, my dad saw it in the trash, pulled it out of the trash, and was like, Lauren, I really think you would love this program. You should do it. And I was kind of like, I'm not sure, Dad. But I saw that they go on this amazing trip every spring break. And I was like, well, I'll sign up for it. I'll give it a shot, and I'll see what happens. And I'm really glad that my dad saw it in the trash because it was the best decision I made of MIT.
Thank you, Dad.
Yeah.
And what was the first, what is it like to come into Terrascope as a freshman? Like, what do you do first?
Yeah, so Terrascope is unlike any other class that you will probably ever take or have ever heard of even. And the first day, I remember all the students, we sat down in the lecture hall, waited for the professor who got up. At that time, it was Sam Bowering. And he gets up and spends probably the first half of the lecture introducing the problem, saying your mission for Terrascope is going to be to eliminate carbon dioxide emissions over the next 100 years.
We are all about that.
Yeah.
I just want to jump in here to note the materials from this particular class are on MIT OpenCourseWare. It's the 2009 version of the course 12000, Solving Complex Problems. Check out the syllabus, the readings, and especially the students' big final project presentation and website about their work. We'll put up a link in the show notes. Now back to the interview.
I hear the reflection, or rather the echo of that question in your TEDx video.
Yeah. So it turns out it is taking me a lot more than a semester to answer that question. Yeah, I have a feeling I'm probably going to be trying to figure that question out for the rest of my life and my career. But he gave us this question and then sat down. And that was the last formal presentation he really ever gave. And the rest of the 3-month semester, it was us as students grappling with it, not having any direction, not being told this is where you should go with it, this is how you should address it, but just being like, have at it. Here's a real world problem, solve it.
Wow. So this is college, huh?
Yeah, apparently this is college. I was just like, this is overwhelming.
Yeah. So do you remember something, from your first few weeks as you started to grapple with this? What happened?
Yeah, so there's a lot of confusion for like the first month where all students are kind of like, we don't know what to do. We've never been in such an open-ended environment. Like, we've always had some structure. We've had some teacher giving us deadlines, giving us figure this out, figure this next thing out. And here you kind of organically, like, you come to class and you're just like, I don't know what's going to happen today. Like, some student will probably get up and talk for a little bit, try to share ideas, try to organically generate discussion, but like, we don't know where we're going. We're all lost and confused. And eventually you start to get sort of a leadership group that just organically emerges out of all of it. So my year, it was really myself and 2 other females that became some of my best friends here at MIT, really coming together and starting to drive the class, being like, okay, we need to answer these key questions that are sub-questions of how you eliminate carbon dioxide emissions, such as what's the right level of carbon dioxide emissions to the atmosphere? What technologies are out there? How much energy do we need to provide in 100 years? And sort of just working together to break that problem down and then attack the smaller little pieces, come back together and build it back up.
And what was the answer?
So I think our first time that we did it, we added up all the costs, figured out how much energy we needed, and we're like, we just spent 3 times the world GDP. That's a problem.
That's a solution.
It's a solution. We decided that probably wasn't the best solution, though, so then we kind of redid it. And we ended up using a lot of carbon capture and sequestration and a lot of renewable energies. It was sort of the big pieces of the puzzle that we pulled together.
Fantastic. And that was that was the first semester. And you spent 9, right? How many more semesters at MIT? 7 more
7 more semesters at MIT and then my PhD.
Right.
Still trying to figure that out.
Did you come out of that experience with an understanding of, like, a Terrascope way of approaching a problem?
Yeah, it definitely teaches you how to take a big complex problem and break it down into sub-problems and something that's manageable. How do you start with this big unbounded question and actually start making progress as opposed to be floundering in an unknown space?
Were they guiding you towards that in some way, the instructors?
There's guidance along the way. You oftentimes don't realize at the moment it's guidance.
The unseen hand.
Yeah, so they would do things like they would sometimes have mini projects to sort of help you start to figure out, well, what are the sub-questions I need to be asking? And they would have undergrad teaching staff as well as graduate and actual professor teaching staff. Sort of when you're in a discussion and just totally lost, would throw out an idea and a suggestion and sort of help you without pedantically saying, this is how you break down a problem, but showing by example, basically. So actually, initially, we hadn't considered cost at all, which is part of the reason we ended up being so far over the global cost. And we were in one meeting as we're getting ready for the final presentation, and one of the teaching fellows goes, well, how much is this plan going to cost you guys? Like, are you willing to spend enough to make this happen? And we were like, I never thought about that. Like, I was so confused. I was like, cost, money, No one told me as part of eliminate carbon dioxide emissions, I had to worry about money. So then it was a big sort of push at the last minute where we're all frantically trying to put out cost numbers, trying to generate numbers and come up with a final global figure. And that also completely changed how we thought about it. Because now you're like, wait, there's this other constraint, this really important real world constraint that we hadn't thought about. And then having to sort of say, okay, like, it's not just about carbon, it's all these other issues on top of that.
Do you think there's value in working through on a problem, not having taken something important into account, and then running up against that, oh, I hadn't even thought about that, versus having somebody kind of guide you, earlier in the process? Yeah,
it definitely makes you more wary the next time you're facing a big problem, always asking the question of what haven't I considered yet? So whenever I go forward now, I'm always thinking, what big assumption am I making that I'm not even realize I'm making? And trying to sort of distill that down and say, okay, do I actually know everything implicit in what I'm doing that I haven't explicitly said?
You know what's amazing about this is, and I wonder if it affected your research career in the future, it's very collaborative, right? It's not, and it seems to be a kind of a collective form of problem solving. Was that a big part of what makes it great?
Yeah, I mean, I think anything collaborative is simultaneously the best and worst part, depending on what time of the project you are in.
Right.
Julia is one of the other leaders from my year of Terrascope, and we just hit it off. Like, she will probably always be the best work buddy I ever have. Just the two of us together, like, we were so on top of it. We complemented each other perfectly, and that sort of collaboration between us made the project so much better. Because it's like what I naturally lacked or didn't want to do, she excelled at. In addition, it also forces you, at the times that suck and you're like, this collaboration kind of sucks, it's because other people have different viewpoints and they have those other perspectives of the cost matters or the social implications matter, where I maybe naturally didn't want to think about it because it's hard, and they're sort of forcing you to be like, there's this really complex arm that you haven't considered, look at it. And I think in the end, it makes your solution a lot stronger and a lot more robust.
And I bet it also, it's preparation for the real world where different people do have opposing views and you still need to work with them to get somewhere.
Exactly. Yeah, it's as close to a real world simulation as I think you could get.
Were there elements of what went on in Terrascope, like getting out in the field? There was that trip that initially attracted you that performed an important complement to the first semester?
Yeah, so the second semester, I opted to take the version of Terrascope where you work in a small group of about 3 to 4 students, one-on-one with a professor. And the professor I worked with was John Oxendorf, and we were trying to look at low-carbon concrete and if there are cement alternatives that could help reduce emissions from that sector. And that research project was probably one of the most influential because it was really the first time that I was like almost one-on-one working with a professor, really engaged in a narrow topic as opposed to that broad one. And John actually became sort of my life mentor for the rest of MIT and beyond. And that relationship definitely would not have developed without Terrascope.
Maybe take us to a teaching moment with John.
Yeah, so for our project, when we were looking at low carbon concrete, one of the ideas that we were testing was somebody else's theoretical idea that you could precipitate out cementitious material from seawater if you bubbled carbon dioxide through it. So you could sequester carbon dioxide and make this material that had cementitious properties replacing cement.
Let's riff on cementitious for a minute. What does that mean?
Oh, it means that it has cement-like properties so that it is a binding substance. So it was so empowering. We actually got to reach out to a bunch of different professors at MIT and ask, like, can we use your lab space? We want to test this out. We want to get a giant bucket of seawater. We want to bubble CO2 through it. We want to see if we can make this precipitate. We want to see if it's cementitious. And it was just mind-boggling how many professors responded, being like, absolutely, come on in. We're going to help you out. And I remember the moment when we were in the lab, we'd literally gone to Revere Beach to get the seawater. Like, came back with this giant bucket of seawater. We're bubbling CO2 through it and saw this white precipitate form. And it was just so phenomenally awesome because the 3 of us were there, the students, and then we also had John there. We had another professor there. We had a postdoc there and a PhD student, like all surrounding this like little beaker of water, bubbling CO2 through it and seeing this white precipitate form. And you're just like, the excitement in the room was almost unlike anything I'd felt before.
And was it cementitious in the way that is going to change the world?
So when we did the cementitious test, turns out it had no cementitious properties. So that was a bummer. But it was also just amazing to have been given the opportunity to sort of take an idea from base state all the way through.
Right.
And just have so many people along the way who are like, we want to help you do this. We want to help you figure out this answer. And there was no other class I've really been in that does that for you beyond Terrascope, where they're just like, you take ownership of your learning, you take ownership of your knowledge, and it's so empowering. Like, honestly, we got water from the actual ocean. We're like, this can't possibly work. Like, how are we going to take water from the ocean, bubble CO2 through it, and get things to come out of it? That seems crazy. So actually seeing it work, it was like, whoa. And also, like, in high school, you're always given labs where you know the outcome ahead of time. Like, they're going to give you a lab and it's going to work out. And as long as you do it right, you get the answer that everybody expected. Whereas this is the first time where you're like, I honestly have no idea if this is going to work remotely close to how I expect it to work. So when you had that expectation in reality happening, you're just like, maybe I do know things. Maybe I can do this. Maybe like I'm not as crazy as I thought.
Yeah. It sounds like there's a takeaway here about having a really powerful kind of immediate experience that it's empowering. It's deeply empowering, yeah?
So how did either that incident or something like it, how did it change you?
So first of all, it made me excited to do science. And that was the first time I'd really had that excitement, that pure just joy from a learning experience. And then the second one was also realizing that I could do it. I remember as a junior at MIT, I was in a meeting with John Oxendorf, and he asked me, Lauren, how are you going to change the world? And that was the first time I'd ever thought, I'm capable of changing the world. And for me, that changed my perspective on everything. Because now, instead of thinking, what class am I going to take next semester, or what am I going to do to earn money after I graduate, it became, how am I going to leave my mark? How am I going to solve this big real world problem? And having somebody who I looked up to have the faith in me that I could do it, it changed my life.
Beautifully stated, yeah.
Okay, you got that kind of confidence and sort of almost the license to declare that you are allowed to change the world. How are you changing the world?
Yeah, so I've really felt like I've committed to using my career and using my life to figure out if I can actually answer that question that Terrascope threw at me. How do we eliminate carbon dioxide emissions? It's a huge question, and I think there's many different ways that I'm trying to tackle it. One of it's with my own research. I do a lot of research now looking at climate change, trying to better constrain where we are heading given carbon dioxide emissions and projected future emissions and the real problem we're up against.
So is this computational modeling? So what kind of work is it?
I do a mixture of everything. So I actually often describe climate science as more like CSI, because unlike a normal sort of science experiment where you can run as many different versions of it as you want, we only have one Earth system. And I can't see what happens if I don't add carbon dioxide to the Earth system. All I get is this one shot. So a lot of my research is trying to take different pieces of the puzzle and put them together and say, how do they all tell a coherent story? So that's going to involve some modeling, some computational modeling, of course, but it also involves looking at what observations we have. I'm trying to say, what have we seen? How do we understand what we've seen with models, but also with just basic physics and chemistry and biology? And putting all of those different pieces together and saying, can I understand this system in a coherent way?
So where do you think it's going?
I would say we clearly understand where we've been, I think, in the Earth past. We understand glacial cycles. We understand the interaction between carbon dioxide and temperatures. The real uncertainties now that we're trying to answer is, well, where are we heading? How fast are we heading there? And how bad could it be? And that's sort of what I consider to be the really exciting part of the work that I do, is trying to say, okay, like, I've often heard it compared to we're basically in a large sort of military tank driving in the fog towards a cliff. We know that our tank has bad brakes, but we don't know where the cliff edge is, and we can't see it because of all the fog. So what we're trying to do as climate scientists is sort of remove some of that fog and say, can we see where that cliff is? And can we also then maybe look over that cliff and see, are we going to fall 10 feet or are we going to fall 200 feet? And so better just constraining the risks that we're up against.
And having come up with more information about that, what actions do you want people to be taking around that? And how do you connect people, help them understand, okay, we've got some better answers, now what?
Yeah, so the now what question is what I always love to talk to people about, because I find that to be the more empowering one as opposed to like the problem definition one. So a lot of what I think is important for the now what is really showing people what our energy system is made of, where our energy comes from, how we're using it, making people sort of connect driving their car to the oil emissions, to the carbon dioxide in the atmosphere, or turning on the light bulb to the coal-fired power plant, and thinking about the consequences of those things, but also presenting the alternatives and saying, well, we could use solar, or we could use wind, or nuclear could be a great option, but what are the downsides of each of these? And getting people to actually engage with the whole spectrum of the problem, not just the carbon side, but also think about that cost side that I initially ignored, and think about the environmental impacts in other ways of mining rare earth metals. But just try to get a more holistic view of the problem. I feel like alone is really empowering for people.
Could you recap a bit of the story of your student who you talked about in the TEDx talk? Because I think that one, that's an interesting way of reaching people around these issues.
Oh, Jack. Yeah. So one of the most amazing things I've been able to do while as a PhD student at Harvard is get to help teach. And the class that I taught is close as Harvard is able to get to Terrascope. Terrascope is so unique to MIT. Harvard may never get there. But the second half of that class is we give the students pretty much the same problem I had. We give them the challenge of eliminating carbon dioxide emissions in the US by 2050. And I had one student, Jack, who initially was so disengaged in the class. He would be asking me questions like, well, do I really need to do the mandatory reading? Like, is this actually going to be on the test? He was coming to section and he was kind of on his phone the whole time, wasn't really paying attention. But then when we give him this problem, it's as though a light bulb goes off. Because he initially started the problem being like, well, I'll just use solar, I'll use wind. But then I sort of pushed back a little bit on him and I was like, well, how much land area do you need for solar? What are you going to do when it's night out? What are you going to do in winter when we don't have as much sunlight as we have in summer? And the more I sort of pushed back on him, the more engaged he became. And he was like, okay, well, I'm going to use batteries, or I'm going to come up with this other solution. And by really challenging him that he had to think about these other issues, while at the same time showing him, I believe in you, I know you can do this, here are resources to look at, let's have conversations about it. It was just an unbelievable transformation that he went through. And by the end of the semester, he's producing this whole paper for me. And he's asking me, he's like, what other clubs can I do at Harvard to think about these issues? He's going to be going to Oxford in the fall to think about these issues even more, going to be working on airborne wind energy. And it was just amazing to see that within the span of a month, going from, do I have to read this, to constantly coming to my office with questions.
It sounds like what you've just described with Jack is a little bit different experience than what you had in Terrascope. With Jack, you're providing more guidance, for instance, as opposed to Terrascope leaving you to really wrestle with these things. Reflect, if you could, on, the time and the place for these different ways of engaging people.
Yeah. So when you give somebody very little guidance, the upside of it can be huge, but the downside can also be huge. You can sometimes end up with this sort of bimodal distribution of outcomes where you have people who take it and run with it and really excel and are so empowered by the experience of being like, you gave me a real world problem, you had faith I could solve it, and you just let me go. And other people who are just like, I don't even know where to begin. This is way overwhelming. I'm going to disengage from it. So I think what we try to do at Harvard with a little more hand-holding is try to sort of take both those distributions and bring them closer together. And you don't tend to get as many of the sort of upside swings of, I am now going to go change the world and do this for the rest of my life. But you also have fewer students who feel like they got nothing out of the experience. They're always going to walk away being like, I learned something. You've kind of put it more in a sort of nice bow-tied box for them where they feel like even if they didn't love it and get really involved, there was a lot that they got out of it.
If you were to plot Jack on the Yale Six Americas scale, would he be in the concerned but not that engaged category? You're trying to reach people in that space. Yeah.
Yeah. So I think initially he would have been even lower than the concerned but not engaged. He would have been the mildly aware of the issue, maybe.
Yeah.
So getting to see him move up to the spectrum of extremely engaged to wanting to work on this problem in the energy realm for the rest of his life is really cool.
Do you think that this is generalizable? Meaning, again, I'm now moving to the next stage of not just learning to change at Terrascope or at Harvard, but in the world at large. I feel like these are very, whether Terrascope or the class you taught at Harvard are very time and commitment heavy, right? You're talking about spending probably hours with your students or being the recipient of that kind of mentorship. Do you think that is what all of us need, or is there something which can transform us with a little bit less commitment?
I think you can definitely be transformed with less commitment. One of the things I've been trying to do now is take what we teach at the Harvard class and parse it down into something that you could maybe go through in an hour or 2 hours, either on your own through an online platform or guided through in a workshop seminar. I've actually done such a seminar with 3 different groups now. One was just a local community in Connecticut where they had no background in energy. The demographic was basically they were middle class and concerned about the environment, but didn't necessarily know a ton about it. And even just an hour having them think through a small portion of the problem, decarbonizing your electric grid, almost everybody walked away being like, wow, I know so much more about the problem than I did before. It's so much more complex than I ever thought. Right after the exercise, one of the women, probably in her mid-50s, early 60s, came up to me, and she hadn't really done a lot of work, but was very involved in environmental issues. So she was on the board of a number of different small environmental programs in Connecticut. And she had familiarity with all of these issues. Like, she knew a lot about wind, she knew a lot about solar, she knew a lot about what the government was doing in Connecticut. But one of the things she'd never really been forced to think about is how you actually integrate all of these different technologies together, and the challenges of dealing with intermittency once you have a lot of wind and solar. And that was one of the things that we really sort of covered in the seminar, was when they had to design their electric grid, it forced them to deal with intermittency. And she came up afterwards and was like, wow, I never thought I would say this, but natural gas might be a huge part of the solution. And just hearing people sort of change their mind about what they originally thought, for me, was huge.
What do you think was the key to reaching her in that way? Was it just getting in the room with her for an hour, or something about the way you went through the information? Or
I think the key was really just letting her play with the data. I think when I just tell people, oh, this is the solution, or oh, these are the problems, you then have like, oh, well, do I trust Lauren or not? Like, does she know what she's talking about? Or I don't necessarily agree with what she said because I heard these other things that I like better. But going there and saying, okay, here is a model. I can show you all the inner workings of the model of our energy system. And all it's doing is calculating carbon emissions. And letting people fiddle with the knobs and sort of say, okay, if I turn up solar, what happens to my costs? What happens to the land area? If I turn up natural gas, how does that impact it? And really letting people just play around and test their own assumptions is huge.
So can people access that 1 hour seminar somewhere, or are the resources available?
I'm currently working on making it available online. That's been a long, ongoing project, and hopefully at some point it'll be up and online. But right now, if anybody were to email me, I'd be happy to share what I have with them.
in the interim, is this based on the Climate and Energy Challenge?
Yeah, so it's based off Dan Schrag's Climate and Energy Challenge, but it's a much abridged version that I've sort of parsed down, tried to make it more digestible, less numbers to fiddle with, and hopefully a little more intuitive to play with.
Yeah, because that class it has run on edX. I don't know if it's up there frequently, but
yeah, it's on edX.
Somebody wants to commit 30 or 40 hours.
Right.
They can get there, right? Yeah.
Yeah. We have the 40-hour version, but not the 1 hour version.
Yeah. I can imagine the 1 hour is going to get more play out there.
Yeah, hopefully.
So one final question. I feel like when I hear so many of these things, that, okay, you're at MIT, how can organizations or communities that don't have the resources of an MIT or a Harvard expose their members, citizens to this kind of problem-solving capacity?
I think these big questions, you don't need the resources of MIT to really go out and start digging through and finding your own answers. Just available publicly on the web is so much information out there. There are a lot of people out there that want to engage with these really big questions. And the seminar that I ran in Connecticut, it was set up just by a local woman that I knew who contacted me. It was like, I know you've been doing this. Will you come lead my community through it? And I was like, absolutely. Like, I love talking to people about these questions. I love helping them think through some of the challenging parts of it and sort of leading them through the big questions beyond just wind, solar, what little bits you read about in the news, and making them think deeper and think about, okay, if I were to really design this system, what would it look like? But the information I was giving them, it's all publicly available online. Like, if you go on the EIA website, the Energy Information Agency, you can find all of this, a wealth of data out there. And you can really start to dig into those issues and really start to understand, well, where is my energy coming from locally? What are the options out there? And start just engaging with a problem on a deeper level.
We hope you've enjoyed this extended interview cut. Please be sure to check it out in context in the prior produced episode, episode 2, on free choice learning in universities. The Climate Conversations podcast is engineered and edited by Dave Lashansky. project and media support is by my MIT Open Learning colleagues Laura Howells and Michaela Joyce. Please subscribe and rate us wherever you find your podcasts. Join the community on climate.mit.edu and be in touch at Twitter, climatex_MIT, and Facebook, group named MIT Climate. For my co-hosts Rajesh Kasturirangan and Dave Damlur, I'm Kurt Newton. Thanks so much for listening.